Alright, on to part 3, and looking at the rest of the chapter, or rest of this section, it looks like it might take 4 videos for me to do all this, so I apologize. This first section is really, really long. It's got a lot of information in it, and even when I teach this class on campus, it takes me usually more than a full class period to get through section 1, just because there's so much information in it. So I'm going to try to do this for all the sections from now on, and hopefully there will not be 4 videos per section. But this first section just has so much stuff in it. So I think there's 2 really important things left to do, 2, maybe 3 in this section, and several of them are on the calculator. So I've got some more notes to show you on the paper, but I'm also going to pull the calculator in as needed. And the next thing in this section that's really important is being able to find zeros of factored polynomial functions. So if I know I have, for example, a polynomial ax squared plus bx plus c, and I also know that this thing factors into x plus m times x plus n, just as an example to help us out with kind of some generalities here. So there are some terms here in this section that they sound like they're asking you to do lots of different things, but they're really just asking you to do the same thing, but say your answer differently. So the zero of a function is any value that makes it equal 0. So we would set a function equal to 0, and then we would solve for x. So our final answer would be x equals blank, 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 whatever. Could be multiple answers, could be one answer. But a 0 is any number that would make the function equal 0. So we set the function equal to 0 and we solve for x. Now, for most people, the solving is the hardest part, but there are other ways to do this. Another way that we could do this is by looking at the factors. So if I know f of x can be written as x plus m times x plus n, whatever will make this 0, since it's factored, what we're saying is this number times this number equals 0. The only time 2 numbers multiply to be 0 is if one of them is 0. So if we can get our polynomial factored, then we can split it up and set each individual factor equal to 0. And we'd get negative m and negative n as our zeros. So those factors, directly from those factors, we can see that, oh, it's just the opposite of the number that we see inside there. And another way we could do this is on the graph of the polynomial. So if this is ax squared plus bx plus c, if this is our f of x function, these x-intercepts here are going to be in the form negative m comma 0 and negative n comma 0. Now x-intercepts are points on a graph, so they will be in that ordered pair format. But the special thing about x-intercepts is their y-coordinate is always 0. So if we can look at a graph and we can identify the x-intercepts, we could just pull those values out. So we can get it from the factors, we can get it from the graph, and all of those are zeros. And we can link all three of these concepts together, the x-intercepts, the factors, and the zeros. And this is not just true of a quadratic equation, which I have written as an example here. It's true of any polynomial that we could factor. Even if it's not factorable, we could still link zeros to the graph. We just might not be able to factor it. So I want to show you this in some actual examples. Let's say that f of x equals x squared minus 8x minus 9. And I want to find the zeros of the polynomial. And I'm not saying how to do it. It's your choice how to do it, however you understand the best to do it. And it's really optimal to understand all of the ways. That way you have options. But as long as you really understand at least one of them, then you should be able to get the answer. So the zeros are anything that make your function equal 0. It doesn't mean plug 0 into the function. It means what makes it equal 0. So really they're asking us to solve this equation. So we can do this, since it's a quadratic and I recognize how to factor it, we could do it by finding the factors. So when we factor this, we're looking for two numbers that multiply to be -9, but add to be -8. So it's going to be a -9 and a +1. Now it says these two numbers multiply to equal 0. That means one of them must equal 0. So I can now separate it. And this is only true when you have it equal to 0. If it equals anything else, you can't separate it. It's not true to say, well, if two numbers multiply to equal 8, that means one of them must be 8. Because that's not true, because 4 times 2 equals 8. This only works for 0. So now I can solve these separately just by moving my constant over. And we've got two zeros, +9 and -1. So if we were asked for zeros, this is how we would write the answer. If we were asked for factors, we just did that a second ago. It's x minus 9, x plus 1. And always notice, this is always going to be true, that when we pull that number out to say it's a 0, the sign changes. And the reason for that is because of the solving. Because we set the factor equal to 0 and it moves over to the other side with the opposite operation. Sorry about that. My webcam went out again. So it kept doing my voice, but you may have not seen me writing. But I was able to get it restarted. So I was talking about the link between the factors and the zeros. And they're just opposite signs. So if I see x minus 9 in the factor, it's x equals +9 in the 0. We can also figure this question out by looking at this graph. X squared minus 8x minus 9 equals 0. And I'll show you exactly what this graph looks like. Well, I'll show you roughly what this graph looks like. If you were to type this into y equals in your calculator and look at those x-intercepts, it would give us an x-intercept at -1, 0 and at +9, 0. So the x-intercepts for this graph are -1, 0 and 9, 0. And notice that all three of these answers are using the same numbers. They're just writing them differently. X-intercepts are points. And those same two numbers, 9 and -1, Those are x values, so they go in the position of the x coordinate. So as zeros, we're just saying the value. As intercepts, we're writing them as points. And as factors, we change the sign. We're doing x minus that value. X minus that value, which changed it to a plus. And all three of these are always going to be related within a function. You could potentially factor any polynomial by looking at its graph. And we have a project for that next week. So you'll be able to use a graphing calculator, and I've actually got some instructions on there on how to get to a good graphing calculator on the internet, where you just graph the polynomial, identify the intercepts, and voila, you automatically know how to factor it because you know the intercepts. So in the interest of time, I'm going to move on because I also want to show you real quick how to do this on your calculator. And then in my last video, I'm going to talk about the models, polynomial models. So we can also find zeros on a calculator. And I'll pull the calculator back up just a second. So if we wanted to find the zeros of f of x equals, and I'm just going to do something crazy. And I'm really hoping this has zeros. X squared minus 5x plus 9. Well, we just talked about the link between zeros and factors and intercepts. So I'm going to go straight to my calculator. This thing does not factor. So I can't factor it, but that doesn't mean my zeros and my intercepts still don't match. They're just not going to be nice whole numbers. So in my y equals, I'm going to type in x squared minus 5x plus 9. And when I graph, I always like to do zoom option 6. That will always take me back to a standard window. And notice, and I knew this was going to happen, notice that this parabola doesn't ever touch the x-axis. It has no x-intercepts. Therefore, it has no real zeros. So right now that's our answer, because I just made this up off the top of my head. Let me see if I can change it real quick before my 15 minutes is up. Let's find the zeros. I just spelled that two different ways, sorry. For g of x equals x squared minus 10x plus 4. And I'm pretty sure this one's going to work. So x squared minus 10x plus 4. Zoom 6. And this one does have x-intercepts. We can see there's one real close there to the origin and one real close there out close to 10. I did zoom 6, which is the standard window, which means right now everything's going to 10. Now to actually find that, that real value without having to estimate, you can go to second trace, which is the calc list. Anytime you have a graph and you want to know more detailed information about a graph, while it's on your screen, go to second trace and you can calculate different things. And we want to know the zero. Now it won't tell you x-intercept, and that's why we need to learn this information, because the calculator expects us to know that zeros and x-intercepts are the same thing. So I'm going to say 0. And it's going to want to know a left bound, a right bound, and a guess. And sometimes this is tricky when we have like a vertical line. So this is what I suggest. Go to where you think it is. For your left bound, hit the left button twice and hit enter. Go back to where it was. For the right bound, hit the right button twice and hit enter. And then for your guess, go back to about where you think it is. And it says x equals 0.417 approximately. And then we would do the exact same thing over again for the other side. We would have to go to second calc and find the other 0 and do a left bound and a right bound and again.